In today's lecture, we will discuss the mean value theorem and the rules theorem. So these are very important theorems in calculus. So let us begin with the mean value theorem. For this, we will consider a function f of x which is continuous on the interval a comma b, and it's also differentiable on that particular interval except at the endpoint. Then there exists at least one value of c, and this value of c lies on the interval a comma b, such that the slope of the tangent line calculated at the point c is equals to the slope of the secant line. What does it mean actually? We can understand this with the help of an illustration. So let's say we have a very smooth curve which is defined on the interval a and b. So the value of this function at x equals to a corresponds to f of a, and the value of the function at x equals to b, this will be f of b. The mean value theorem states that there will be at least one value of c on the interval a and b, that means lying between a and b, such that if we consider the tangent line, if we draw a tangent line to this point, at that particular point, let's consider it p, then the slope of this tangent line, which will be f prime of c, this will be exactly equals to the slope of the secant line. So the secant line can be obtained by joining the endpoints a and b. So this will be a secant line. So this point, let's call it b, and this point is a. So this is what the mean value theorem means. So the slope of the tangent line at that point p will be exactly equals to the slope of the secant line, which is given by f of b minus f of a divided by b minus a. So the best way to understand the mean value theorem is with the help of an example. So let's try a few numericals. So here we have to obtain a value of c in the interval 1, 5, which is satisfying the conclusion of the mean value theorem for the function given by f of x is equals to x cubed. So we have a cubic function here. So let us begin. So we are given that the function f of x is equals to x cubed. So the derivative of this particular function with respect to x will be 3x squared. Now the mean value theorem states that the slope of the tangent line calculated at x equals to c, so this will be equals to 3c squared. So this must be equals to the slope of the secant line. So that means f of 5 minus f of 1 divided by 5 minus 1. So that means when we solve for this value, this will give us a value of c, and the c is going to lie on the interval 1, 5. So let's try it out. So we have f of x as equals to x cubed. So this means f of 5 will be 25, or this will be 125, and f of 1 will be equals to simply 1. So that means 3c squared will be equals to 125 minus 1 divided by 5 minus 1. So we have 3c squared equals to 124 divided by 4, and 124 divided by 4 is 31. So the value of c squared is equals to 31 divided by 3. Let's take the square root, so we're plus or minus square root of 31 over 3. So c will be equals to plus or minus square root of 31 over 3 is 3.21. However, we are only going to consider the positive value of c, which is 3.21, because this is the only value that lies in the interval 1, 5. So using the mean value theorem, we have obtained one value of c. At least there will be at least one c, where the slope of the tangent line calculated at that point will be exactly equals to the slope of the secant line. Fine. So let's do another problem. So we have to obtain the value c in the interval 1, 5, satisfying the conclusion of the mean value theorem for the function given by fx is equals to 1 over x. So let us begin. So we have the function given by 1 over x. the derivative of this particular function with respect to x is negative 1 over x squared. We need to find a value of c which lies in the interval 1 and 5 such that f prime of c is equals to f calculated at 5 minus f of 1 divided by 5 minus 1, which means that the slope of the tangent line calculated at that particular point c, which we need to find, is exactly equals to the slope of the secant line. So we have f prime of x is equals to negative 1 over x squared. So f prime of c will be negative 1 over c squared. So this is equals to, so f of x is 1 over x. So f of 5 will be 1 over 5 minus f of 1, which is 1, divided by 5 minus 1. So this is 4. So we have negative 1 over c squared equals to, so 1 over 5 minus 1. So that is negative 4 divided by 5 multiplied to 4. So the 4 and 4 goes away, the negative and negative goes away, and we are left with c squared is equals to 5. So the value of c will be plus or minus square root of 5. Square root of 5, 2.24. However, we will only consider a positive value of c, 2.24, because this is the only value that lies in the interval 1, 5. So with the help of the mean value theorem, what we have done is we have found a value of c, which is 2.24, and at this point, the slope of the tangent line will be exactly equals to the slope of the secant line. And if we try to understand this with the help of a graph, so let's say, so this is our x-axis and this is our y-axis, and we have the function f of x given by 1 over x. So this is the graph of 1 over x. We'll consider the interval 1 and 5. Within this interval 1 and 5, there lies a point c equals to 2.24. So let's say this is the value c. And at this point, if we draw a tangent line to the curve, so this is denoted by the green line. So this is going to be a tangent line. This is exactly going to be equals to the secant line. So to the slope of the secant line. So the secant line can be obtained by joining the endpoints, which is, that means the point f of 1 and f of 5. So the green line, slope of the green line is exactly equals to the slope of the blue line. So this is what the mean value theorem states. Right. Let's move on to the next problem. So this time we have the logarithmic function. So let's begin. So we have the function natural log of x. Its derivative with respect to x will be 1 over x. We need to find a value of c which belongs to the interval 1, 5 such that f prime of c is equals to f of 5 minus f of 1 divided by 5 minus 1. So since f prime of x is 1 over x, so f prime of c, this will be equals to 1 over c. And this value is equals to f of 5. So f of x is log of x. F of 5 will be natural log of 5 minus natural log of 1 divided by 5 minus 1, which is 4. Now, natural log of 1, this value is always 0. So we have c is equals to 4 divided by natural log of 5. So let's find this value. So this is approximately 2.49. So that means, and also it belongs to the interval 1, 5. So if we try to sketch this problem, so that's it. This is our y-axis and we have our x-axis and our logarithmic function looks like this. So this is the point 1. We'll consider the point x equals to 5. So there lies between 1 and 5 a point c, which is 2.49 or approximately 2.5. Then this point, at this point, what we'll do, we'll say that the slope of the tangent. So first we'll draw a tangent line at this particular point A, and we also draw the secant line. Let me use a different color here. So this is our secant line. So at that value of c, the slope of the tangent line is going to be exactly equals to the slope of our secant line. So this is what the mean value theorem states. So we have successfully obtained the value of c. So now we will talk about the Rolle's theorem. So the Rolle's theorem is a very special case of the mean value theorem. So let's first read out the definition. Consider a continuous function f of x defined on the interval a and b and differentiable on a of b except at the endpoints. If the value of the function at the endpoints are equal, then there is going to be at least one value of c within that interval such that the slope of the tangent line to the curve calculated at a particular point c is 0. What does it mean? So we have a smooth curve. So this is our interval a and b. The only condition that we need to follow here is that the function has the same value. So this is f of a, which is equals to f of b. Then the Rolle's theorem states that there is going to be a point on the x-axis, that means lying within the interval a and b, there is going to be a value c such that if we find the tangent to this curve at this particular point, then the slope of this particular tangent line is going to be equals to 0. So this is what the Rolle's theorem states. So there is going to be at least one value of c when the slope is going to be 0. Fine. We'll try to understand the Rolle's theorem with the help of few numerical problems. So let us begin. Problem number 4. So here we have to obtain the value of c in the interval 0, 1, which satisfies the conclusion of the Rolle's theorem for this given function. So let us begin. So we are given the function f of x is equals to x raised to the power of 5 minus x squared. So let's take its derivative with respect to x. So this will be 5x raised to the power of 4 minus 2x. So from Rolle's theorem, we also have to check before applying the Rolle's theorem whether if the value of fx is the same at the endpoints or not. So we have f of 0, which is given by 0 raised to the power of 4 minus 0 squared. So this is 0. And f of 1, which will be equals to 1 raised to the power of 5 minus 1 squared. This is also 0. So clearly f of 0 is equals to f of 1. So that means here we can apply the Rolle's theorem. That means we need to find the value of c belonging to the interval 0 and 1 such that the slope of the tangent line to the curve f of x calculated at x equals to c is equals to 0. Right. So our f of x, from the f of x we have the derivatives at x equals to c. It will be 5c raised to the power of 4 minus 2c, and this is equals to 0. We can take c as the common factor. So we have 5c cubed minus 2 equals to 0. Solving for c, we have c equals to 0 or c cubed equals to 2 over 5, which implies c is equals to the cube root of 2 over 5. Now c cannot be equals to 0 because this is not included into interval. Here 0 is excluded. So c could only take the value the cube root of 2 over 5, which is approximately 0.74. So this lies within the interval 0, 1. So here we have, using the Rolle's theorem, we have found out a value of c within the interval where the slope of the tangent line is going to be equals to 0. Fine. So let's do another problem. We need to obtain the value of c in the interval 0, 5, which satisfies the conclusion of the Rolle's theorem for the given cubic polynomial function. So let us begin. So we are given the function f of x is equals to x cubed minus 7x squared plus 10x. First, we will verify if the value of the function is equal at the endpoints or not. So we'll begin by calculating f of 0. So 0 cubed minus 7 times 0 plus 10. So this is going to be 0. And f of 5, this is equals to 5 cubed minus 7 times 5 squared plus 10 times 5. When we use a calculator, this is going to give us the value 0. So here clearly f of 0 is equals to f of 5. So that means the value of the function at the endpoints are equal, or we can apply the Rolle's theorem, which tells us that there is a value, at least one value of c belonging to the interval 0, 5, such that for slope of the tangent line to the curve f of x calculated at c, this is equals to z. Fine. Since we have a function f of x, so f prime of x, that will be equals to 3x squared minus 14x plus 10. Fine. Now we will find the value of this slope at c, x equals to c. So this will be 3c squared minus 14c plus 10. And we'll find the value of c by equating it to 0. What we have here is a quadratic function. So we can use the quadratic formula. So c will be equals to negative of negative 14 plus or minus square root of negative 14 squared minus 4 times 3 times 10 divided by 2 times 3. So this is 14 plus or minus 76 divided by 6. So c will be equals to 14 plus or minus. So that means we have two values of c. Let's use a calculator to obtain that value. We have 0.88 and 3.79. Now both the two values belong to the interval 0, 5. So that means there will be two values of c where the slope of the tangent line to the curve f of x at those 2 points will be 0. So Rolle's theorem says there will be at least one. So here we have obtained two values of c. If we are to sketch the graph of this particular function, then we will have on the interval 0 and 5, this graph is going to have a shape. So here we have two values of c, one at 0.88 and the other value is obtained at 3.79. So at both the 2 points we can see if we draw a tangent line, so this will be parallel to the x-axis, meaning its slope is simply 0. So this is how we can use the Rolle's theorem to obtain two values of c. See you in the next class.